ladies and gentlemen.
Hi, everyone. I'm Nurse Jill with Super Simple Dosage Calculation. I'm here to help your life in nursing school, medical school, pharmacology school, whatever that you're in, be a whole lot easier. So let's get started. Okay, everyone. So to get us started, I have a few simple rules that I would like for you to keep in mind while we're going through dosage calculation problems. These rules are a few that I created back about a decade ago whenever I was in nursing school and I was helping my friends to pass dosage calculation. I actually started working on this whenever I was in chemistry courses, and it seemed to work really well with a lot of different questions. And when I got to nursing school, it actually ended up working with pretty much every single question. So, the method that I'm going to teach you is my custom method that's based on dimensional analysis as well as some algebra components, but they're hidden in there, so you're not going to really notice them. Don't let that intimidate you. Dosage calculation is fun. It is so much fun and it's easy as well. So I've taught thousands of students at this point my customized method, and I also have a book that I recently published on Amazon. So if you guys want to go and check that out, you can find out more. But let's go ahead and start with a question, and I'll explain these 7 simple rules as we go through. Number 1, a child weighs 33 pounds and needs a medication dosed at 10 milligrams per kilogram. How much medication should be administered? Well, first off, we want to identify what the question is actually looking for. So that's your rule number 1. Find out what they're looking for. This one is not very specific. It just asks how much medication should be administered. So the main thing we want to pay attention to is our labels. We have a label of pounds, we have one of milligrams, and then we have one of kilograms. So find the word medication in question number 1 and see what comes close to it. So we know that 10 milligrams is with that medication. So we don't know if it's in capsules, tablets, or if it's given by IV. We only know we have milligrams. So because of that, that's what we're actually going to use. So we're going to say milligrams for number 1, and we're going to put that over dose because it doesn't tell us a time component. So we always want a denominator that we can solidly end with. So here's a very important rule. After you identify what they're looking for, you want to put it to the left of your equal sign. Now, I've started calling my method the rainbow method after some of my awesome students kind of named it that themselves. So that's what we're going to call it for remembering this very important next step. So whatever comes at one end of your rainbow must also come at the other end of your rainbow. So you got to find that pot of gold. So if you've got milligram as your numerator label that you're looking for, then you want to have milligram as the numerator label that you start with in your equation. No exceptions. That is a rule that you can set in stone. And that's what I like to teach my students. So that way it's very easy for them to do dosage calculation after they get this method down. Now look back at number 1. Find what's in milligram. We only have one component, and it's 10. The next rule is very important as well. Do you see in number 1 how it's written 10 mg/kg? This slash is called a fraction bar. And this is some stuff that you might remember from all the way back to elementary school. But if we're not using math every day, it's really easy to forget things like that. Math is very easy to learn, but remember, it's even easier to forget. So you want to make sure that you are practicing this on a daily basis to get comfortable. But this fraction bar is something that I call my twin. So if we've got milligrams separated by a fraction bar with kg, those two things are together. They're twins that we don't want to ever separate. We can flip them upside down if we need to, so that way these labels will match at the ends of our rainbow, but we don't want to separate them. So let's put 10 mg over 1 kg. Now, in your question, the kg does not have a number. So if it doesn't have a number, that's fine. Always put a 1 with it. That way you've just got a number and a placeholder. Now, the next thing you're going to do is put a multiplication sign. And here's another rule. you know that if you end with kg here, you have to have a kg label up at the top. Now, there are a lot of ways to do dosage calculation, and I absolutely do not criticize anyone's personal preference. If you like ratio and proportion, if you like desired over half, that's great. Do that, do whatever makes you happy and whatever works for you, because I am my students' cheerleader and I want everyone to have as easy of a time as possible in nursing school because I know there's a lot of really hard components of it. For myself personally, and for hundreds of students at this point, I teach this method because it works with pretty much every single nursing question. So some of this may seem mundane that you're doing, like I might want to do a conversion or something separately. Again, that's personal preference. I do this for simplicity, hence why I call it super simple dosage calculation. So I'm going to keep my conversions within my equation. That way I keep everything precise and I'm used to doing it this way every single time. So we know that 1 kg is equivalent to 2.2 pounds. So that's a conversion factor. And if we don't have something in a question, remember you can always use a conversion factor. And that's probably what's missing if you've got a label that's missing from your question. So this is my conversion factor to transition to the patient's weight in number 1, which is in pounds. So we see the patient weighs 33 pounds. Here's another rule. Everything in between has to have 2 of every kind, like Noah's Ark. So I've got a kg on bottom. That means I have a kg on top. I've got a pounds on bottom. That means I have a pounds on top. So there's 2 of every kind, never more and never less. If there's more in your question, then I'm going to say it, nursing teachers, it's probably a distractor. Now, not for real life when we're giving medication. Things like this, they matter. But for dosage calculation, we're really wanting to focus on labels and making sure that we know how to set this formula up. So I've got to get to my denominator of dose. There's nothing else left in number 1, so I'm just going to put it over 1 dose. And again, I'll only have one of that kind. So I've got an upside down rainbow here at the end. I've got dose that matches dose as my last denominator. So I've started with milligram, which is the numerator label that I'm looking for. I've ended with dose, which is the denominator label that I'm looking for. I have 2 of every kind in between. So now I'm ready to work it out. Now, again, this is totally personal preference, but for me, and it may just be because I'm a nerd, I like to do the up and down and then multiply kind of thing in my calculator. I trust my calculator 100%. I use a basic calculator, and that's what I recommend practicing on at home. Our phones have some really good smart calculators and different things like that. But when you get to your actual exam, they're probably going to have you use a basic calculator. So you kind of want to get used to that at home. So I put mine in 10 divided by 1 times 1 divided by 2.2 times 33 divided by 1. A lot of my students prefer to go across and then divide by the bottom. Again, that's personal preference. If you're doing that, you can do 10 times 1 times 33 or just 10 times 33, and then you can simply divide it by 2.2. You can leave out on the ones. Those are placeholders. They're not going to change the value, but they're just an option depending on what type of learner that you are. After you plug that into your calculator, you're going to get a weird number. It's going to be 149 point lots and lots of nines. So we know we have to round that, right, to a whole number. So that's going to equal 150 milligrams per dose. Okay, so let's look at another. Let's look at number 2. So a patient requires 2,000 milliliters of fluid to be infused over 12 hours. The drip factor is 15 drops per ml. Calculate the drip rate in drops per minute. We know we get lots of IV questions in nursing or medical school, and these are really good ones to get accustomed to. And again, they're going to work really well with my customized method. So first, on number 2, identify what you're looking for. It says calculate the drip rate in drops per minute. So I know that I want my answer in drops over minute. I'm going to put my equal sign because I know whatever goes to the left of my equal sign will match what comes to the right of my equal sign. So this end of the rainbow matches that end of the rainbow. So with number 2, I look and I identify what's in drops, and I have 15. Now that's attached to ML, and I want to keep those attached because, again, those are my twins and I don't want to separate them. So I'll put it under the 15 drops. I put 1 ml, and then I have ml on bottom. So my next rule says I have to have an ml as the next numerator factor. So we look in the question and we have 2,000 mLs. All right, next we look and see what other numbers and labels we have left. So all I see is 12 hours. I know I'm looking for a time component because I ultimately want to find out how many drops per minute. So I know I need to use my time component. So I put that over 12 hours. And then at the end, again, we can always go with a conversion factor. And this may seem lengthy. Some people really, want to make it very, very fast. I can assure you, after 10 years of doing this and teaching it again to thousands of students, it can be very, very fast. You just have to practice it and get used to it. Minimum, I recommend trying to do at least 3 to 5 practice questions every day until you become very comfortable with this method. After that, then try to do 1 or 2 a day most days so that way you can just stay in shape with that. Math is kind of like working out. If we work out one day, it's not going to build those muscles for us to be strong for all years to come. So we have to consistently practice this in order for it to work. So I've ended with minutes, which again is my upside down rainbow. I have milliliter, milliliter, hours, hours, and I know I'm ready to calculate this. So anytime you get to the denominator label that you're looking for, you're done. You've set up your equation, go through the steps, make sure you have it in order, and then plug it in. I also recommend clearing out your calculator 2 or 3 times, especially if you're on an exam, because sometimes even basic calculators can have memory and we can get numbers stuck in there that we don't know that are in there. And the last thing I want you to do is to make a mistake on dosage calculation. So after we plug that in, we get 41 point lots of sixes. Now, with drops per minute, we know we can't have anything less than a whole drop, right? Because we can't actually divide a drop. So if we've got 41.6 with lots of other sixes, we know the 6 is going to round the 41 up to a 42. So we have 42 drops per minute. I hope this makes it super simple for you. I plan to be posting videos pretty often on this, so please check back. I would love it if you guys would subscribe and if you would like my videos. Like I said, I've been tutoring and teaching for several years now and have been a nurse for quite some time, but I find that it is a very dire need for people to have help with a subject that I really, really love. So make sure and check out my book, Super Simple Dosage Calculation. Thanks for watching. Bye.